Hello everyone and welcome to this video where we are going to see how to migrate an Android application to a Kotlin multi-platform application. So we are going to start from an empty Android application and we will do all the steps needed to migrate it to a Kotlin multi-platform and Compose multi-platform application that can be run from Android and iOS and desktop and web as well. So uh, that's the main goal, and we are not going to use any templates or something ready. So we will go step by step and see all the steps needed, and to understand every part of the Kotlin multi-platform and the structure of the Kotlin multi-platform project. So I'm using Android Studio here, the Hedgehog version, I guess, which is the Canary version, and I'm going to create an empty activity. I'm just I'm just going to create a new Android application, and we will choose the Kotlin DSL. Okay, I have something that needs to be downloaded. Okay, now we have an empty Android application. We can we can run it to see if everything is working. So as you can see, the app is running and we have this hello Android. Now let's start the steps of the migration of this Android application. Okay, so first we need to change this display mode of the files here from Android to project, so we can see other files, and it's easier to for multi-platform projects. So now we have all of these files. We can see the settings.gradle, which is fine. There is nothing to change here. Also we have the build.gradle, and we have these plugins from the version catalog. Okay, so here we are going to start the migration. So first we have this Android application plugin and the Kotlin Android plugin. So the first thing that we are going to do is to change the Kotlin Android to Kotlin multi-platform, so we can support all platforms. So we are just going to change this one to Kotlin multi-platform, and same here as well. Just we type Kotlin multi-platform there, and here we are using the version of 1.8.10 of Kotlin. For let's just delete all of these dependencies related to Jetpack Compose. We don't need the most of these parts, just to make it simple and to focus on the parts of the migration and the multi-platform parts. I'm just going to keep this activity Compose because we need that one. Also we will change this plugin here in the build.gradle to Kotlin multi-platform, and we will sync the project. We will have some errors in the Android module, of course, so this one needs to be changed to Kotlin multi-platform. And we have a lot of dependencies here. We are going to delete all of these ones because we already deleted these dependencies from the version catalog. So of course you can keep all of these ones, but just to make it simple, that's why I'm going to delete them. I just want to keep things simple. So we have a problem with Kotlin options. Okay, so for Oh, I guess for this one we'll keep it Kotlin Android. I guess we'll have problems if we change it to multi-platform, and we'll add Kotlin Android here and Android. So in the now we have applied the Kotlin Android plugin to the Android module. So I think that it's not supported yet to use the multi-platform plugin here, and we just removed all of these dependencies that we don't need actually. So here we'll have some problems in the project because we deleted the compose dependencies. Okay, so now let's see how we are going to add the compose multi-platform dependency. So instead of using Jetpack Compose, we will be using Compose Multiplatform. So first we will need to add the Compose Multiplatform Gradle plugin, which is just Compose Multiplatform and ID equal org, and this is the, I'll just copy and paste dependency, and we need to add a version of Compose here. So just going to add Compose, and I will add 1.4.3 as the version of Compose. I'm going also to upgrade Kotlin to 1.8.20. So now we can apply this Gradle plugin in the project gradle.kts, and also we can add the Compose multi-platform to the Android. So let's just add this one here, and now we have added the Compose multi-platform dependencies to the project. Now we've added the Compose multi-platform plugin to the project. We can apply the Compose multi-platform dependencies. Can just implementation of Compose material 3. So this Compose is coming from Compose multi-platform, which is they make it easier in Compose multi-platform. You don't need to specify any dependency. You need to just type Compose, and you will find all other dependencies like material and UI, foundation, runtime, animation. So you can find all the other dependencies just under this Compose. Okay, now most of our problems are gone. We still have this preview issue. I'm going to delete preview for now, since Compose multi-platform doesn't support previews. You can keep it by adding the Jetpack Compose preview dependency, but I want to keep it simple here. So now if we run the app again and see what's going to happen. So now you have the exact same app running with Compose multi-platform. So this Compose code now is using Compose multi-platform, which is used just Jetpack Compose from in the Android module. So it's the same actually. Now let's see how we can add the common module or the shared module of this project. So we can share our code and add our code there. and use it from other platforms. So we'll go to the root project folder, and just we are going to add a new directory. So I'm going to name it common. I prefer common, it looks better than shared. So now inside this common we are going to add a build.gradle.kts file. So this file is going to, just with this file we can say that, hey, this is a module. So in that build.gradle.kts, first you are going to add the Kotlin Multiplatform plugins, and I'll keep adding the Compose Multiplatform plugin for later. Just I want to sync the project now, so we can see some hints. Also we will add a Kotlin block here where we are going to specify the targets. So we can say Android and GVM desktop, which is, this stands for desktop, and we can add iOS x64 and iOS ARM64 and iOS simulator ARM64. So this different iOS targets is just, this is the simulator, and these ones are just the different iOS devices, different iPhone devices or iOS operating systems, which is just running on a different CPUs. So now for after adding these targets, let's try to sync the project, because we need some hints to keep going. Let's first add this command in the settings.gradle, so we can read this command as a module of the project. So I'm adding the command to the settings, and let's try to sync the project. Okay, we have some errors now. Okay, so one of the errors is saying okay, so the problem now is that the Android, let's try to comment all of these ones and sync the project again. So okay, we need at least one target. Let's try to add the GVM target. Okay, it's working now. So we have this command as a module here, and we can just bring back the other targets. So the problem with Android is that when you specify an Android target, you need to add the Android library, the dependency grader plugin. So add just com.android.library. Also we'll need to add this one in the plugins in the root project Gradle. So we'll add Android library. So the shared module is going to act as a library for our Android application, and we can just try to sync again now. Okay, it's working. We have some problems that we are going to fix. So the structure here is we are adding a new module, a new Kotlin Multiplatform module. So we are going to specify the Kotlin Multiplatform plugin, and we are specifying here the Android library plugin as well, to say that, hey, this is an Android library. And here we have the targets. So you can add as much targets as you want. So you can add, I don't know, Linux, Mac OS, Windows, which is, I guess, Mag, something like that. anyway. So you can add all the targets that you want. You can add watchOS, tvOS. So all the targets are can be added from here. And so this is where you specify the targets. So now let's see how to add dependencies to these targets. So let's open this source sets, which is, so we're going to so inside these source sets, we'll add something called common main by getting and dependencies. I think that I'm going to disable the copilot for a while because it's annoying. Disable completion. Okay, so here where we are going to specify all the source sets of our project. So we'll see what a source set is and how to create a source set, and what are the already defined source sets. For example, this common main is just already defined source set. We are just getting this source set, and here we can, which is the common main. So this source set is the shared code. So we can add the dependencies that we want here. So first I'm going to add the Compose Multiplatform, com.jetbrains compose, and so I can add the Compose Multiplatform dependencies. So compose dot can add the compose dot material and compose material 3. So let's fix this issue with Android first, so we can keep moving on. So specifying an Android library here requires this Android block, so where we are going to give some informations about the Android library. So namespace, we will name it, so here the namespace of the library, like the package name. And we have the compile SDK, so I'm just going to choose 33. Also we have the default config, where we need to specify the min SDK, and let's say 24, or I'm just typing random things here to make it run. We have a problem with the Compose Multiplatform. It's org.jetbrains, not com.jetbrains. Okay, it's confusing. Okay, we have an error here which is saying the Compose targets UI kit are experimental and may have bugs, but if you still want to use them, add this Gradle properties. So here we are adding iOS targets, which is going to enable the experimental UI kit. So let's add this line to the Gradle properties. I'm just going to delete all of these to make it simple. Let's say that this is for Android. iOS. So by setting this to enable to true, we'll be able to use UIKit from Kotlin native from these targets, and we will be able to just target iOS. So let's try again. It's working now, so all of these errors are gone. I'm not sure what this is for, but I think that we can delete it. Don't need this one. So now we have we have a working multi-platform plugin. Let's start by adding some folders here and add some code. So just I'll add a new directory to the common. I'm going to name it src, and we have already the suggestions from the IntelliJ idea. So common main slash Kotlin. So inside this one, you will be able to add, like your code inside this common main. So this common main is called a source set. So this is the dependencies that we are specifying here in the common main is going to be added to this source set, which is the common main. So this is a source set in a Kotlin multi-platform project. Let's just copy this and create the new package with this name. And now here we can add a new Kotlin file called app. So, and we can go to the Android part and to the main activity also for this. So we can just try to copy this UI theme and paste it here. Okay, let's add a new package UI to keep the same structure. So we need to just rename the packages, but it just work. There is no additional things that we need to do. I'm just going to remove these parts that is related to Android, like the dynamic colors, and I'm going to delete this one as well. So which is Android specific code, so let's get rid of it. So here we have just simple light and dark color schemas, and we have the theme of the app, applying the schemas and the typography, and everything should work just fine. Now let's see the main activity. We have this simple code here. So let's start by moving this grating and the main activity. So let's move this this code, and let's create new composable. Can call it app, for example, and paste the code here, and it just works. So then there is no additional things that you need to do. So if you have already screens with Jetpack Compose on Android, you can just, or components or whatever, you can just copy paste everything and it's going to work. So now in the main activity, we are going to call this app here. He's not going to recognize it, so we need to add the implementation of the common module. So implementation project, and we'll add the common module here. Now let's try again and sync the project. So I see that it's here already. So I have some warnings here. I'm going to see how to fix these ones. So this warning is saying that the Kotlin Multiplatform is max tested with Android Gradle plugin version 8, but I'm using 8.2. It's working fine, so I'm just going to add this line to build.gradle to suppress this warning. Also, we have this warning said that the project is following the version 1 of the Android source set layout, and he's okay. So let's say the version. Let's use the version 2 of this one. So that's what these lines does. So this is just to suppress the warning, and this one to change the source set layout version to the second version for the Android. And we can sync again. So okay, we have no warnings now. Let's try to run the application and see if it is working with the code inside the shared module. And I think that we have an error. There is something not working correctly. Okay, so we have that the current target is 1.8 and compile debug and so it's a problem of target compatibility. So I forget about this one. Let's fix it. So here inside the Android target, I'm going to specify the GVM target. So compilations dot all. We will specify Kotlin options, and we have something called GVM target, and let's put that on 1.8. So this is going to support the Java 8 and anything above that. Also for the desktop, I'm going to add the GVM toolchain and specify the GDK version to 11. So we can work with any Java version from 11 and above. So for the desktop, we can't just specify Java 8 because it's not supported. This is the minimum Java GVM target supported by Compose Desktop. So let's sync and try to run the project again. We still have an issue here. Current target is 11, so let's see what's going wrong. So the GVM target was causing a problem here. I'm not sure why, but this shouldn't happen. So let's try adding the other source sets and see. So we have the common main source set, and we have also the Android main source set. So we can specify Android specific dependencies here. Android space. Also we have desktop main target, which is for desktop. Okay, so I have these targets. So let's try to sync again. I'm not sure if this is going to work. That's what I hate about working with GVM is these issues of target compatibility, which is annoying. Okay, I'm going to try to add the compile options for the Android library here. Let's see if this is going to change something, because I'm specifying the version 1.8 for Android. It just have nothing to do with desktop. I'm not sure why. It's just okay. Now it works fine, but I'm sure that this is not needed. But anyway, let's try to run the app. Okay, so we have a running Android application from a shared module, which is this common module that is used inside our Android module. So let's rename the Android module from app to Android for better readability. So rename directory to Android and rename module to Android. So, and we'll need to rename it here as well. in the settings.cradle. Let's sync the project, and we have our Android module here and our common module. So let's try to run it again. I think that we need to, okay, we have the new Android configuration. So now let's try to let's add the desktop target. So I'm going to add a new directory. I'm going to name it desktop, and I'm going to just go with the same approach, a file with build.gradle.kts, which is going to specify that so Gradle knows that this is a module. Also, we need to add the module here. So say that we have a module for desktop, and now we just need to add the plugins for this target. So the Kotlin Multiplatform and the Compose Multiplatform. Let's just remove the Android library plugin. Also, we'll open Kotlin and add JVM target with JVM toolchain 11 and with Java. So, and we have source set. So this desktop module actually is a Kotlin Multiplatform module, but with just a JVM target. So that's how this works with Kotlin Multiplatform. And same with JavaScript for web modules and JavaScript modules. It's the same, that we are going to add a new Kotlin Multiplatform module with just a JavaScript target, and it's going to be our like JavaScript module. So now let's try to sync the project. So it's for desktop, it's different from Android. For Android, this module is just an Android module. Actually, it's Android application and using Kotlin Android, but for desktop it's different. It's Kotlin Multiplatform module with just the Java target. We have problem here, and resolved reference. Okay, JVM toolchain. So toolchain is wrong. Let's try again. So okay, it's working now. So we have this desktop, and we have this desktop module. So there is some additional things that we need to specify for Compose desktop applications. We need to add Compose desktop here to say that this is Compose desktop module, and we add application main class. Let's call it just main kitty. We're going to create it later. So this main class is the name of the class that contains the main function that's going to run our desktop application. And we'll add this native distributions, targets, formats, and could add just target format DNG for macOS, and just bring all of other targets, MSI for Windows, and dip for Linux. And we'll specify the package name, so we can say just KMP. It's package version 1.0.0. I think that 1.0, just two numbers, is not going to work with desktop. I guess one of the operating systems that doesn't accept this version, so it requires that the version contains 3 numbers. Okay, so now we will add the source set. So new directory src JVM, and we can just have this one here. So inside our Kotlin package, we need a new Kotlin file named main. So inside this main, we will create the main function that's going to run the desktop application, which is main. Okay, let's just keep it like that for now, and sync Gradle, so to have the Compose desktop dependencies. So in the JVM main, you can add Compose implementation, Compose desktop common, and Compose desktop current OS to get some dependencies for Compose desktop. And inside this main, we are going to add this application, which is going to enable us to run a Compose desktop application. I'm just going to add a simple window with a title, and on close request, just exit application. So this exit application is coming from the application scope. If we say this dot, we see exit application. There is few other things with the application scope, like this tray and some other stuff. So here inside this window, we can just again call the app composable from the common. We need to add the common here. So project and common module. So now we will have the common module inside the desktop module, and we can call the shared code. So we have this one here, and that's it for the desktop target. That's how you can create a new desktop module that uses the shared module and run it on desktop. So if you want to run this code, we can just go to Gradle here. Okay, wait a second, we have a warning which is saying JVM main is never used. Okay, let's ignore this one. To run the desktop application, you can go to Gradle and desktop tasks. I can't see the desktop tasks. I think that there is something wrong with this one. Maybe something is missed. Let's it should work. I'm not sure why. Okay, let's try from the terminal. Let's just type Gradle desktop run and hit command enter, and yeah, it's working. And we have this desktop application saying hello Android. Okay, it's not Android, it's desktop. We are going to fix this. So now I think that I'm not sure why this one it doesn't refresh here. No problem. So we can just run this command on desktop. Also, we can add a new configuration for desktop called desktop app, and here the grader really helps here. So I can just say desktop, and then okay, there is problem. It should just autocomplete this one. I think that it needs some time. Anyway, so here we have our configuration. We can delete this one, and we have our Android and desktop configurations, and we can run our desktop app easily. Okay, so what else? There is a problem here. I see here that task list not built. So let's try to enable this one. I think that this is going to do it. This makes Gradle sync slower. Okay, there is no problem. So let's apply it. So I used to use IntelliJ IDEA, which is this one was enabled by default. So now let's try to sync Gradle and see if it's going to work, because it's really helpful, you know. I think it's working now. Okay, it's working. So if we go to the desktop module here, we can see the tasks, and we can see this Compose desktop tasks, and we can see the run and run distributable, run release, package for current OS, which is package distribution for current OS. Let's try this one, for example. Okay, it said that I'm using invalid GDK configuration found. Let's go to project structure. Let's go to settings. I'm not sure if the GDK is specified correctly here. So we'll go to build tools and Gradle, and yeah, let's choose this one. Let's choose Java 11. Let's try this one more time. Packet distribution for current OS. Okay, it's working now. So this one is going to create a package distribution for your current OS, and I see that this project is config. Oh, okay. So this it requires Java 17, so we need to change this one to just Java 17. I'm not sure. I'll choose Java 18 of Oracle GDK, because I'm not sure. The JetBrains runtime sometimes sometimes I have problems, but when I change to OpenGL. So this could take some time, but it's going to create the package distribution for this current OS. So if you need to get the distribution for Windows, for example, you need to run this command from a Windows machine, and same for Linux. And yeah, it's completed now, and I have this installation here, and I can install this project, this software. Also, it's going to be here inside the build and compose and binaries and DMG, and you can see this DMG file. I'm not sure why the app is named like that, but okay, whatever. So that's how you can build so you can build even a distribution file for desktop, and you can link this one with your CI and make it and publish it with releases on GitHub. So that's it now for desktop target. So let's move to iOS. Let's move to iOS for now. So here for iOS we are specifying all of these targets. So for desktop we have Android, for Android we have Android target, and for desktop we have this JVM desktop. But for iOS, if you see what we have here, we will have these ones. We have iOS ARM, that's 64, and so we have three different targets for iOS. So we don't need to repeat things three times, and it doesn't make sense. So here for iOS we are going to create a new target, name it just iOS main, and this target is going to be the parent of all of these three ones, and it's going to be shared. So that's how you can create a source set. So let's try this, and we are going to type iOS main. You can name it whatever you want, and by creating, that means you are going to create something. If we try by getting here, it's not going to work. If we try this one and try to sync the project, this is not going to work. It's just said Kotlin source set with name iOS main not found, but because there is no target with this name here. So if we put this one, for example, iOS x 64 main, it's going to work now. but we can't just specify three targets for just one target. It's just iOS in the end. So what we are going to do is are going to create a new target called iOS main by creating. That's how you can create target. So you can even create a GVM target shared between Android and desktop, since they both use GVM. uh, so now we are going to say val iOS x64 main by getting, and this one. So we will call these three targets, and inside the iOS main there is something called uh, depends on, so which is going to specify the graph or the dependencies. So we are going to say that iOS main depends on common main. So we have common main as a parent, and iOS main depends on common main, and then we can specify this, that iOS x64 main depends on this, which is the iOS main. So with this, so I'm going to explain this and what it means exactly. Just a second, I'm looking for something. So let's see this one here. Just want to make this smaller. So if we see here, we have common main, and everything is depends on common main. So we have, let's make it smaller like that, and yeah. So we have common main and everything else here. So iOS main, for example, depends on common main. So iOS main is going to just add it right there, and we are going to have iOS main here, which depends on common main. So depends on is going just to link it with an arrow. So iOS main depends on common main, so we have an arrow from iOS main goes to common main. Same here, GS main depends on common main, GVM main depends on common main. Also we have this iOS x64 main depends on iOS main, so it's the same as this one. So we have this all three targets for operating systems, Windows and Mac and Linux, and all of three of them depends on desktop. So we are doing the same here. We are putting these ones to depend on iOS main. So that's what this code does. So we are creating a new target, and our new source set, let's say, and we have these three already defined targets depends on this source set, and this source set depends on common main. So that's what this code does. And now we have just a single place to specify dependencies for iOS, and this should work. Okay, so now this module should support iOS, but let's see how we can run this inside an iOS application. First, we need to add a new plugin, Gradle plugin, which is the CocoaPods plugin. I'm going to use CocoaPods in this project, and I prefer using CocoaPods. Well, it's the same, the default Gradle integration and CocoaPods are basically the same, but with CocoaPods you can just import external iOS libraries from CocoaPods. But anyway, I'm just sticking to a single option. This is the CocoaPods dependency. Of course, I'm going to link the project in the description, so you can just copy all of these dependencies. So we have this CocoaPods plugin, not exactly dependency, but whatever. And I'm going to add it here, Kotlin native CocoaPods, and I'm going to add it in the common as well. So in the common we will add this Kotlin native CocoaPods plugin, and let's sync the project. Okay, it's saying okay, he wants me to add a Compose block, so yeah, we are going to do this just right now. And after adding the Compose plugin, we will see that we can say Compose, and let's put this version to 1.0. Let's try again. Okay, it's working now. There is a few other things that you can do. You can say summary, which is you can say common. So what this called for the home page. You can specify the link of this if it is a library or whatever. So I'm just going to put my GitHub profile, but you can specify whatever you want there. Also iOS deployment target, so I'll choose iOS 14. We have a pod file here, but we are just going to set this later because we need to create a pod file first. And we have this framework block here where we can specify base name for this Compose for this module. So I'm just going to call it common. And what this means for in the iOS project, you are going to import common to have this module there. Also, you'll specify is static to true. It's false by default, but it's not going to work if it is false, I guess. So we need to specify this to true. There is still some issues there with it. So now we need to create the iOS application. So I'm going to go to Xcode, and I have Xcode here. I'm going to create a new project. So I can show you the window now. Here it is. So I'm going to choose iOS and choose application. Next, so product name KMP app, Swift UI and Swift. You can choose whatever you want here. So next, now we will specify this this project inside our KMP project. So I'll go to idea projects. Oh no, not idea project, Android Studio projects and my KMP app, and I'm going to create it there. And I will hit create. So now it's created, and you can try to run the iOS application. Of course, it's just iOS for now, just Swift. There is no Kotlin multiplatform here. So we have the application running on iPhone. It's just taking a few time. So this is the hello world from iOS. Okay, good. So now we need to close this project. So close it and stop tasks. And we have this KMP app added here. We need to rename it the folder to iOS. You can keep it, but I just want to name everything with its name. So we have Android and desktop and iOS here. Inside the iOS, we need to add a new file, which is called pod file, which is going to be used by Compose. Now let's go back to common and comment this one. I'll add pod file project dot file, and we'll go back iOS pod file. So here we are specifying the pod file to Compose. So that's it. Now we need to make some changes, to add some code to the pod file. So to make it work, so we need to add the target. So what is the target of this? And the target should be the name of the iOS project, with which is KMP app for my case. And can add use frameworks, and here we could specify the the multi-platform module. So pod common, this one needs to be the same name as the module here of the multi-platform, and we need to specify the path as well. So this is the path, which is the same path of the common module, and that's it for the pod file. Now let's go back here and try to sync again. Let's sync the project and see what we are going to have. Okay, we have an issue. Okay, I'm specifying the path, the wrong path. It's just common here because no, the path is correct, it's not wrong. Oh, I just type user framework. It's used frameworks. Just a typo. And now we can see we can sync the project and see. It looks fine. Looks fine. Now we can run the pod install. So if you go to common, and we have this Compose here, we can double click on pod install. You can run it on Gradle as well, but I prefer this one. Now after running pod install, you can see XC workspace here added, and pods and a lot of stuff added here, which is good. This means that everything should work fine. Now before we can be able to run this on iOS, we need to create some specific code to iOS. So we can create iOS main Kotlin, and I'm going to just copy this package name to create new package. So as you see here, let's just create the source set of all the targets. So Android main Kotlin and new package. So same for desktop main Kotlin and package. So we have all of these source sets here, and we have this iOS main as well. So now we can just change this Android, and we can add something platform. We can just type a function get platform name, and it's going to return a string, and we can just use expect. So here is how you can use expect actual in Kotlin Multiplatform. We can copy this and go to Android. It needs to be in the same directory, and we can call it platform.android. Sometimes if you call both files platform and they are under the same package, some things could go wrong. So make sure that you call it platform.android, and the same for all other targets. So we'll change it to actual and equal Android. So same for desktop. Say desktop here, and same for iOS. Are going to iOS. So now the error is gone, and we have this expect, and we have these actual functions. So that's how you can access platform specific APIs in Kotlin Multiplatform. So you just need to add this expect, and you make the it's just an interface and implementations, but it's expect actual. So like you specifying this protocol in the common, and you make the implementation in each platform, so in iOS, desktop, and Android. Then you can use this one in common code. So that's how you can use platform specific APIs in common code, so just this way. So we can change this Android with get platform name, and now if you try to run desktop, for example, it was just hello Android in desktop. Now it should be hello desktop, and yes, it's hello desktop, which is good. Now let's see how we can run the iOS. So let's add the main file. For this one, let's say main view controller, something like that. You can call this whatever you want, and we can just say compose UI view controller, which is what this is going to do actually is going to return a UI view controller which is used in UIKit to this one. We can use it on iOS project to display like a screen or whatever, and it's going to accept a content, a composable content. So it's from compose we can create this one, this UI view controller. So you can call app here. Oops, need to import app, and now we have this compose UI view controller, which should just present app here. I'm going to make a small change here. Just I will add a box with modifier align center. I'm just going to put this center of the screen. So size, fill max size, and alignment center. So we have an error. Let's remove this one. Okay, now let's try to use this in our iOS project. So I'm going to run pod install again. So every time you make a change in the shared code in any Kotlin code and you want to use it in iOS, you need to make this call, this pod install. Now I'm going to open the iOS project which is inside this XC workspace. So if you open XC code proj, it's not going to work. You need to open the workspace. Let's open it in Finder and just double click on this one, and Xcode, the project is going to be opened in Xcode, and it's saying that the project is ready. So let's try to run it now before any Kotlin Multiplatform starts. Okay, we have a failure here. So what's the problem exactly? Oh, I think that I forget about something, which is for the Gradle properties. There is a few things to add to enable Objective-C interop and a few stuff like that. So we have this flag. We need to add this enable C interop, which is related to KMP, and also for Kotlin native we need to add this. Add this one, cache kind none, which is bad actually. It is going to make the build slower and it's going to remove any cache from build, but for now Compose iOS is not going to work without this one, and they are working on fixing this, and when I fix it, the build for iOS is going to be way faster than the current build time. You can sync the project now. and of course again we will need to run pod install and open the Xcode project, and let's try again. Let's try to run the application one more time. Okay, as you can see, it's working now with the pods and all of this stuff. So now let's just use our Compose multiplatform composable in this project. So what we are going to do actually, if you see here in the iOS, we have this function which is returning UI view controller. So if you are familiar with iOS development, UI view controller is something related to UI kit, which is like activity in Compose in Android, like activity or fragment, something like that, which is just presenting a UI. We need to just present this UI view controller inside our iOS project, but we are using Swift UI here. If you use UIKit, it would be easier. So for Swift UI, we can just make something called struct. Let's say compose view. Let's call it some compose view. It's going to return UI view controller representable. Okay, so now we have the two functions to override here, which is one of them make UI view controller and the other is update. You can keep this update empty, and for the create we need to import common first. So let's try it. Let's see if it's going to work. Import common. So it's working. This is our common. This is our module, our Kotlin Multiplatform module. And now here we need to return a UI view controller. So we are going to make return main kitty dot main UI main view controller. So where this main kitty is coming from, if you see here, the file is named main. So when you have a function like that, just Kotlin is going to create an anonymous class or something like that, which is called the name of the file plus kitty, so main kitty, and this class is going to contain this but object or whatever singleton object, which is going to contain this method main view controller, and that's what happens here. So we have this this main kitty containing this method main view controller. So if you have another file called, for example, second or home, so home, and you have function inside home, to call that function you need to type in iOS home kitty dot the name of the function. So that's how it works. Let's type something, let's say plus kitty, and yeah, just accept function name. That's how it works. And now for this compose view, we can just use it directly here inside this one, inside the iOS app, and let's try to run it and see. Let's see if it's going to work. So it's building the project now, and here we go. It's hello iOS, and it's working just fine. So that now we just created 3 modules, three projects, 3 targets: desktop and Android and iOS. And we created the common module, which is a shared module for all of these targets, and we created everything from scratch, and it's running. And now I think that with this you can have a better understanding on the Kotlin multi-platform structure and on the source sets and everything else. Now an additional content here also, we've done this expect actual, so that's the main goal of this video. It's not about making fancy apps and using just animations or cool UI or whatever. So the main goal is just to have a solid base and to understand the basics and to understand everything, how it works, uh, before making something great with it. So when you understand something, you will have the full control of it, and you can build something with it. Let's add some bonus now. We can add the web target. So let's just add it. Uh, so let's add the web. I always make the web the last one, because just the web is still experimental, and you may have something not working there, or but yeah, that's totally fine. So we add this JS browser target with the new IR frontend, or backend, or whatever. So let's add this uh, JS main dependencies by getting, of course, this one is not required here to add. You can just remove all of these ones, but I'm just to show you how this works. So you can see it, but you can just remove them if you don't need them, if you don't need platform specific dependencies. Also for these sources, Android main, desktop main, iOS main, you can delete all of these ones if you don't need these expect actual, or to specify something like the main view controller or whatever. So now let's sync the project first. Oh, okay, we have some problems. It's saying that I have some problem with the GS target. Okay, there is a flag to enable GS. Maybe it's going to fix this. So for Gradle properties, we need to add it's the same as the iKit one. So to enable the experimental GS canvas, and let's try again with this one. We still have the same problem. Okay, never mind. I forget to add the okay, so I forgot to add the JetBrains Maven URL, which is this one, which is the dev URL for Compose Multiplatform. So it works for Android and iOS and desktop, because desktop is stable and iOS is still in alpha. But for GS, we still need to add this link here, this URL for the JetBrains space, and it's because the web target and the Compose web is still experimental, so that's why it's not published on Maven Central yet. But so now it's working, and we have this GS main here, and we can add the new. We will have an error here saying that we are not using this on GS. Yeah. We can just create an actual function, make it easier for us, and we have this on GS. I'm going to rename the file to platform.js, and let's type web here, and yeah, this should work. This should work just fine. So now we need to add a new module for GS. The same approach, like adding new directory called web, and I'll just copy this build.gradle and make the changes there. So what we are trying to do now is to create the GS the web app module. So we need to add this from JVM to GS IR browser, and we have binary. Okay, let's add this for later. And GS main, and we are importing common main, and for this it's compose experimental and web dot application. Let's try it. We need to add web here as well, and let's try to sync the project now to see if everything works fine. Okay, now he's reading this web as a module. We can add the code for this one now. We can say src gs main kotlin, and the ID is really helpful here. So we can specify the main file containing the main function that's going to run our application. So here, to run the application on GS, I will say on wasm ready, since Skiko is using wasm in web, so are using GS but wasm as well. And we are creating a new window called KMP app. So in wasm, you may get confused between Kotlin GS and Kotlin wasm, and Compose GS and Compose wasm. It's actually the same for web, because even Compose GS is using wasm after all in the background, but here with Kotlin GS your code is going to write Kotlin GS code, so you are targeting GS. But for Kotlin wasm, you are just writing Kotlin code that's going to run on wasm and compile to wasm after later. So that's the difference. So now we have this one here, and we need to add something else to this, which is binaries dot executable. So that we need to, so we can just get executable code. Now there is some missing parts. We need the resources. So we go to GS main, new directory, and choose resources, and we create a new file, create index.html file. So this is going to be the index.html containing our project. I'm just copy paste it, and that's it, which is a simple HTML code with can say KMP app here, and we're adding some styles like margin 0, padding 0, overflow hidden, and we have this canvas here, and we have a script where we are saying that this canvas is going to take the full page, full width and height of the screen, and yeah, that's it. And we have this kiko.js and web.js here, which is going to be generated later, and that's it. I think that this should be enough to run the web app. So now we could go to Gradle here, and we'll search for web and Kotlin browser, and we will run GS browser development run, and we have an issue. So this is weird, actually. It shouldn't happen. So we have this build was configured to prefer settings repositories over project repositories, but no distributions was added by known code. Okay. Let's see what we have inside the settings. Maybe we will change this configuration to prefer project repository over settings repository. So I have this repository mode, which is preferring settings repositories over project repositories. Okay, let's remove this line. It looks that it's not compatible with Kotlin JS. Let's try to sync now, and let's run JS development run. Okay, so it's running now, and we have this nice hello web from the browser. So our application is working just fine on web as well, so which is really good. Same as desktop, you can just get the distribution files uh, from with the web, so you can run, for example, JS development executable distribution. So to get some files, some executable files that you could upload to the server and have this application just working on the server. So it's running now. It's taking this task is that takes a little bit of time, since it's going to generate the distribution files. So I'm not sure if this is going to end up very soon, but well, the JS development executable distribution and JS browser distribution would give you just the distribution files that you can upload to a server. It's taking 13 minutes now. I think 30 minutes. I think that there is something wrong, but yeah, it shouldn't take that much time. I must admit that it was a mistake to run this comment. I was waiting for 30 minutes. Okay, so I'm just going to cancel this. uh, I no longer want this one, but you can try it with JS browser distribution and it will give you something similar to this, which is this one. This is the development executable, so index HTML and skiko.js, the web.js file, and the skiko.wasm file, which is when you take these files you can upload them on a server and have a running Compose web application. So that's it for this tutorial. So that's what we've done so far. We have this iOS application, and let's just update the Android application. I have this Android application. We have this desktop application. My desktop is on dark theme, that's why it's dark there. So, and we have the web application as well, which is so we have all of these running applications here: the web, the desktop, Android and iOS. So I hope that this tutorial was helpful to understand the structure of Kotlin Multiplatform and the Compose Multiplatform project, and how to create these modules and these target modules from scratch, and to understand every single part of this code, and to fix the issues that may encounter you in this progress. And we started by an empty Android application made just with Android Studio. You could apply this approach with an existing Android application, but of course you need to change everything to multi-platform. So if you are using Hilt and Dagger, you will be migrating to Coin. If you are using something like uh, Retrofit or whatever, you need to use Ktor. If you are using Room, you need to use SQL Delight. So there is a lot of multi-platform libraries that you can use to migrate your existing Android application to multi-platform. So this process is could be applied on any use case and on any project, and then it's up to you to just write the code for migration. Just move your code and put it in the common, and just change the libraries that doesn't support multi-platform with libraries that does, and it's going to work as simple as that. But of course you need to have the basic knowledge of how everything works to be able to solve problems and do more complex things with multi-platform, which is really amazing, and you can do a lot of cool things with it. So I hope that this tutorial was helpful, and see you next time.